Hello everyone! For today's video, I would like to discuss about random variables. Random variables. Random variables is assigned a numerical value to each outcome in a sample space. For example, suppose that an electrical engineer has on hand 6 resistors. 3 of them are labeled 10 ohms and the other 3 are labeled 20 ohms. So the engineer wants to connect a 10 ohms resistors and a 20 ohms resistors in series to create a resistance of 30 ohms. So now suppose that in fact the 3 resistors labeled 10 ohms have actual resistances of 9, 10, and 11 ohms, and that the 3 resistors labeled 20 ohms have actual resistances of 19, 20, and 21 ohms.
The process of selecting one resistors of each type is an experiment whose sample space consists of 9 equally likely outcomes. So here's the table of the following sample space.
So now, the important to the engineer in this experiment is the sum of the 2 resistances rather than their individual values. Therefore, we assign to each outcome a number equal to the sum of 2 resistances selected. The function x, which assigns a numerical value to each outcome in the sample space, is a random variable. So, by the way, we use capital letters to represent a random variables. The letter x, y, and z are most often used. So, we can compute probabilities for random variables in this way. The event x is equals 29 corresponds to the event of 920, 1019 of the sample space.
Therefore, probability x equals to 29 is equals to probability of 920 and 1019 is equals to probability of 2 over 9.
So the possible values are 28, 29, 30, 31, and 32.
To find the probability of one of these values, we add the probabilities of the outcomes in the sample space that correspond to the value. There are 2 types of random variables. So first is discrete random variables, and the second is continuous random variables. So discrete random variables, a random variable is discrete if its possible values form a discrete set. This means that if the possible values are arranged in order, there is a gap between each value and the next one. The set of possible value may be infinite. So for example, the set of all integers and the set of all positive integers are both discrete sets. So the example of discrete random variables. A computer chips often contain surface imperfections. For a certain type of computer chips, 9% contains no imperfections, 22% contains 1 imperfections, 26% contains 2 imperfections, 20% contains 3 imperfections, 12% contains 4 imperfections, and the remaining 11% contains 5 imperfections. So we let y represent the number of imperfections in a randomly chosen chips.
The random variable y is discrete because it takes on only integer values.
The list of possible values 0, 1, 2, 3, 4, 5 along with the probabilities for each provide a complete description of the population from which y is drawn.
This description has a name, probability mass function. So the probability mass function of a discrete random variables y is a function p of y is equals to probability y is equals to y. So the probability mass function is sometimes called the probability distribution. Thus, for the random variable y representing the number of imperfection in a randomly chosen chip. Note that if the values of the probability mass function are added over all the possible values of x, the sum is equals to 1. This is true for any probability mass function. The reason is that summing the values of probability mass function over all the possible values of the corresponding random variables produce the probability that the random variables is equal to one of its possible values, and this probability is always equal to 1. So the probability mass function can be represented by a graph in which a vertical line is drawn at each of the possible values of the random variables. The heights of the lines are equal to the probabilities of the corresponding values. The physical interpretation of this graph is that each line represents a mass equal to its height. So let's move the cumulative distribution function of a discrete random variable. It specifies the probability that a random variable is less than or equal to a given value. The cumulative distribution function of the random variable y is a function f of y is equals to p of y less than or equal y. So let f of y denote the cumulative distribution function of the random variable y that represents the number of flaws in a randomly chosen wire. Find f of 2.
Since f of 2 equals the probability of y less than or equal to 2, we need to find the probability of y less than or equal to 2.
So we do this by summing the probabilities for the values of y that are less than or equal to 2. So note that f of y is defined for any number y, not just for the possible value of y. So in general, for any discrete random variable y, the cumulative distribution function f of y can be computed by summing the probabilities of all the possible values of y that are less than or equal to x. So note that f of y is defined for any number x, not just for the possible value of x.
Plot the cumulative distribution function of f of y of the random variable y that represents the number of imperfections in a randomly chosen chip. So first, we compute f of y for each of the possible values of y, which are the 0, 1, 2, 3, 4, and 5. For any value y, we compute f of y by summing the probabilities of all possible values of y that are less than or equal to y.
So here's the graph of f of y consists of a series of horizontal lines called steps. We jump at each of the possible value of y. Note that the size of the jump at any point x is equals to the value of the probability mass function. P of y is equals to p, y is equals to y.